This video is on solid revolution, and so here I have the graph f of x equal to 0.1 x squared, and I want to rotate or revolve this region right here around the x-axis and then find the volume of the solid revolution. And so this region right here is bounded above by the graph of f of x equal to 0.1 x squared, and is bounded below by the x-axis from 0 to 10. And I want to revolve it about the x-axis, so let's revolve it. And we have the solid revolution, and we want to find the volume of this solid revolution. And to find the volume of this solid revolution, what we do is we divide the solid into slices, thin slices, like this. And each slice is just a cylinder. And we would find the volume of each cylinder and then add the volumes of the cylinders together, and then that will give us an approximation for the volume of the solid revolution. And this is one of the slices, and so let's call this the ith slice, and now let's go find the volume of this ith slice. So the first thing I'm going to do here is I'm going to divide the subinterval from 0 to 10, 0 to 10, into n number of subintervals, and so it would look like this. And let's call the first value here, let's call it x of 0, and then x of 1, x of 2, x of 3, x of 4, and then eventually we'll get to the ith interval, and this would be x of I minus 1, and then x of I, and then all the way up to 10. Then this would be x of n. And so if n is 10, meaning there are 10 subintervals, then this would be 0, 1, 2, 3, 4, and then all the way up to 10. And the length of each interval would be 10 over 10 divided by 10, which is 1. But if we divide this interval, the interval from 0 to 10, into 100 subintervals, then the length of each subinterval will be 10 over 100, which is 0.1. And so in general, if there are n subintervals, then the length of each subinterval will be 10 over n. And it's going to be the same thing for the thickness of each disk. And so for this ith disk right here, the thickness of this disk is 10 over n. And so if we divide this solid right here into 10 slices, then the thickness of each slice will be 10 over 10, which is 1. And so let's denote the thickness of each disk as delta x. And so in this case, it'd be 10 over n. And now let's find the volume of this ith disk. And so for the ith disk, which is at the ith subinterval, then right here, this would be x sub I minus 1, and this would be x sub I. And that, which is the difference, would be the thickness of the disk. Now this is x sub I, and so f of x sub I would be the distance from the x-axis up to the graph. So f of x sub I is the distance from the x-axis up to the graph. But f of x sub I is also the radius of this disk. And so the radius of the ith disk is f of x sub I. And then the thickness of this disk is delta x. And so the disk is just a cylinder, and so the volume of the ith disk or the ith cylinder will be pi times the square, the radius times the height. The radius of the ith cylinder is f of x sub y. And the height of this cylinder is just the thickness of the cylinder. And so it will be delta x. But f of x is 0.1 x squared. And therefore f of x sub I will be 0.1 x sub I squared. And so this is the volume of the ith disk, or the ith slice. Now if we divide the solid of revolution into n disks, or n slices, then the volumes of n slices would look like this. This is the volume of the slice number 1, volume of slice number 2, and then volume of the nth slice. And then using summation notation, then we have the summation where I would run from 1 to n. And then 0.1 x squared is just 0.01 x to the 4th. And so this right here, this sum right here, this is volumes of n slices, or n disks. And so the volume of the solid of revolution will be approximately this sum right here. And then if we want the exact volume for the solid of revolution, then we need to divide the solid into an infinite number of slices, meaning we need to allow n to run to infinity. And when n runs to infinity, or approaching infinity, we would write it like this. It'd be the limit of this quantity right here, of this sum, with n approaching infinity. And then when this limit exists, then we would define it as this definite integral right here, which is the definite integral from 0 to 10, because if we look back in the solid, x ranges from 0 to 10. And then f of x is just 0.1 x squared. And then to evaluate this integral, we have 0.1 squared is 0.01, and then we have the pi, and then this is x to the 4th. And the integral for x to the 4th is x to the 5th over 5. And then evaluating from 0 to 10. And so when x is 10, we get 10 to the 5th over 5. And then when x is 0, we just get 0. And then simplify, we get 200 pi. And so the volume of the solid of revolution would be 200 pi. And so we just found the volume of the solid of revolution by using the definite integral. For this particular problem, the function is simple enough that we can actually find this quantity right here, this limit quantity, without using the definite integral. And so let's find the volume of the solid of revolution without using the definite integral. And to do that, we're going to need some of these, one of these formulas right here. And so recall that if we have 1 plus 2 plus 3 all the way up to n, then it'd be equal to n squared over 2, and then plus n over 2. And we're going to need this one, 1 to the 4th plus 2 to the 4th plus 3 to the 4th up to n to the 4th, which is this. A few moments ago we saw that the thickness of each disk, or the thickness or the length of each subinterval, is 10 over n, or just delta x. And so in this case, x sub 0 is just 0. X sub 1 would be 1 delta x, because the length of this interval is delta x. And then x sub 2 would be 2 times delta x sub 3 would be 3 times delta x sub 4 would be 4 times delta x. And so x sub I would be I times delta x. But delta x is 10 over n. So x sub I would be 10I over n. And then this is the volumes of n slices or n discs that we got a few moments ago, right here. And then x sub I, we just saw that it's 10I over n. And then delta x is 10 over n. And so simplify, we get 10 to the 5th over n to the 5th, because this is n to the 4th times n, which is n to the 5th. And then we get I to the 4th. This summation right here is with respect to I, and therefore we can move this quantity right here, the 10 to the 5th over n to the 5th, and move it and place it in front of the summation. So what's left is just this summation with I to the 4th. But the sum of 1 to the 4th plus 2 to the 4th plus 3 to the 4th, all the way up to n to the 4th. And this sum right here is this. And so 1 over n to the 5th times 1/5 n to the 5th, it's just 1/5. And then 1 over n to the 5th times 1/2 n to the 4th is 1 over 2n. And then 1 over n to the 5th times 1 over 3 n to the 3rd is just 1 over 3n squared. And then 1 over n to the 5th times 1 over 30n is 1 over 30n to the 4th. And so this is the volume of n discs or n slices. The volume of the solid of revolution is the limit of this quantity right here with n approaching infinity. And we just saw that this sum right here is this, which is this right here. And as n approaches infinity, 1 over 2n approaches 0, 1 over 3n squared approaches 0, and 1 over 30n to the 4th approaches 0. And so what's left is just 0.01 pi times n to the 5th times 1/5, which is 200 pi. And so the volume of the solid of revolution is 200 pi. And we didn't need to use a definite integral to get the exact volume for the solid of revolution. And that's the end of the video.